Hey everyone, this is Miss Moriarty and I'm here to discuss with us our topic 6.10, which is all about geothermal energy. So a little bit about geothermal energy. We know it is a renewable resource. This stems from the heat energy that can come from the natural radioactive substances found deep within Earth. Very, very similarly to a lot of our other fuel sources, how we go about generating electricity via geothermal energy. You can find here, right? So that a lot of the hot water that can stem from the heat from Earth's core can be converted into steam, turn a turbine, and eventually be turned into electricity. In other cases, right, water can actually be piped down into the ground and heated by the heat from the then mantle, so we can actually directly use a lot of that warm water to then take it maybe around a building, a home, and kind of naturally heat the home or building using that heated water from Earth's core. Areas that tend to have a lot of potential for geothermal energy can be areas like the United States, China, as well as Iceland. They tend to be the world's largest producers in terms of geothermal energy. Now, an alternative to geothermal energy can also be using what's known as a ground source heat pump. So this is actually what I was explaining a little bit in the previous slide there. So this is a technology that's usually installed in homes or in an office building that can actually take the heat directly from the ground and transfer it around the building. By exchanging that heat with the ground, that ground source pump can heat and cool a building using about 30 to 70% less energy than what a traditional maybe coal burning furnace or natural gas furnace or even air conditioners could potentially do. Now, we tend to associate this with geothermal energy, but technically that heat doesn't technically come from geological activity. It comes from storing heat technically from the sun. So how that might work, looking at the image to the right here, so here we can see we're obtaining very, very hot water from underground, typically being pumped right upwards through the compressor here, which is then going to circulate fluid to form a hot gas. That heat is then given off into the house with a heat exchanger there. As that heat is then exchanged, that then expansion valve there expands and cools the fluid, returning it back down right towards the ground for it to repeat the process all over again. Some pros and cons of geothermal energy. We know that is a renewable resource, but only if the water winds up being piped back into the ground for reuse. We know it produces a lot less CO2 emissions than fossil fuel electricity, and there is virtually no release of particulate matter, sulfur oxides, nitrogen oxides, or carbon monoxides. However, some of its cons: it is not readily available everywhere on Earth. Hydrogen sulfide, which is a toxic gas and is lethal to humans as well as animals, can slowly be released when trying to harness geothermal energy. It can be costly because drilling deep into Earth can have very high risk, and so usually there's a lot of upfront cost involved. Sometimes the upfront costs can be so high that a lot of countries, states, or cities, towns don't tend to use that then geothermal energy. So taking a moment and looking at the practice FRQ, describe why geothermal energy would not be useful in all parts of the world. So take a moment, pause the video, see if you can answer this in your own words in your note packet somewhere. All right, let's take a look at our answer key here. So with geothermal energy, remember we know it's not readily available around the world, so its location is very minimal. We know that to use geothermal energy resources, this requires a lot of drilling into the ground. And the deeper down we need to drill in order to obtain that geothermal energy or that heated water can create a tremendous upfront cost and extensive other costs as well. And so people would not use geothermal energy due to that upfront cost. All right, everyone, that is it for our video on 610. Make sure to leave any questions that you may have about the material covered in the video.